All right, so for number 1, we were asked to evaluate this integral. And it said that if we were to simplify, we should use fractions and no decimals. So the first thing I did was I set up my problem on my paper. And I figured out what I would set u equal to. And I decided I would set it to the bottom. So I wrote out my u. And then I took the derivative to find du over dx, which was 10x plus 20. And so I knew that du would be 10x plus 20 dx. After that, since I saw that 10x plus 20 could be represented by 10x plus 20 dx could be represented by du, I knew that I could take that out and just set it equal to 1 over u du. So now the last step I had to do was plug in u, which was 5x squared plus 20, and we know with our log rules that 1 over something is the same as writing ln absolute value of u. So then I just plugged it in to get ln absolute value 5x squared plus 20x plus c, which was my final answer. The second problem was the definite integral problem, and so we had to solve the definite integral and simplify our final answer if needed, and it said no decimals and the graph is not necessary. So then yet again, the first thing we did was we wrote out our definite integral, and we set u equal to the bottom portion, which was 4 minus 2x squared. So we know that du over dx would be negative 4x squared. Du would be negative 4x squared dx. And we also knew that we could take out a negative 1/4 by setting negative 1/4 du equal to x squared dx. So after we did that, we just pulled out our negative 1/4. So we had inside of the integral, we still had 1 over u du. And pretty much, oh yeah, and that was because we had the x squared above, by the way. And then after that, it was the same rule as before. We knew that 1 over u would be ln, so we would just multiply the outside. So it would be negative 1/4 ln of absolute value of 4 minus 2x squared plus c. And then basically we wouldn't need the plus c when solving for the integral. When solving the definite integral, so we would have negative 1/4 ln, and then we would solve the inside of the absolute value for the first part by plugging in 3, and we would solve the second part by plugging in 1, and then we would basically just minus them, and since they're not the same base here, we're just going to have to leave our value at this. And that will be our final answer, negative 1/4 ln of 14 plus 1/4 ln of 2. All right, for problem 3, we were asked to evaluate the integral and to simplify using fractions again, no decimals. So the first thing we did was we set up our integral, and we wanted to get rid of the square root. So what we did is we put it to the 1/2, because that would be the same as the square root, to make our integral a little easier. And then we could basically just set the inside, 4x squared plus 1 equal to u, and get that du over dx would be 8x, and that would make du equal to 8x dx. And then again, we're going to want to pull out a 1/8 to start. So 1/8 du equals x dx. Then what we're going to do is we're going to take our 1/8 and we're going to take it out and set up our u. And we're going to want to multiply the 3x. We've gone over this before. What we are left with here is an extra x, and we are going to basically multiply. It would be the equivalent of 3x over 1 times 1/8. So we would be left with 3 over 8x on the outside, and then yet again in the inside we would have u to the 1/2 du. And then we're just left with finishing and plugging back in u. So we would take the outside of the integral, multiply it in, so we would have 3/8x. 3 over 8 to x times 4x squared plus 1 to the 1/2 plus c, which is our final answer for this one. Okay, for number 4, it was the one where we had the base of e, and we were asked to evaluate the integral and simplify our final answer, again using fractions and no decimals, if needed. So, of course, first thing we did was we wrote out our integral, and then we would have to simplify the exponent. So here we would just distribute this out and get our exponent as negative 9x minus 6, which is what we would set equal to u. So then we would know that du over dx would be equal to negative 9, du would be equal to negative 9 dx, and then we could just take out the 9 by setting negative 1/9 du equal to dx. So then back to our integral, we would take out the negative 1/9 and have that on the outside of the integral, and then set up our u, e to the u times du, because we know that this would be the same. And then after that, what we would do is we would multiply back in the negative 1/9 and plug in our u, so that our final answer would be negative 1/9 e to the negative 9x minus 6 plus c, which is our final answer. I had to switch up my location a little bit, but number 5 was asking us to evaluate this integral and to simplify my answer, again using fractions and no decimals. Okay, so the first thing I did was I wrote out my integral, and what I wanted to do after that was distribute in the denominator to simplify it, and this would be dx as well. So then we know that we could just set u equal to 9 plus 3e to the x, and we know that the derivative of that, du over dx, would then just be 3ex, and du would now be 3ex times dx. So then this worked out super nicely. Since this is 3ex dx, it's the same thing here. We would just take out the 3ex and dx here and set that equal to du, and just have 1 as the numerator. So then we would just have 1 over u on the inside of the integral. And all we would have to do now is plug in our original u at the bottom, and we know because of our log rules that ln, or that would end up being ln of absolute value of u, and so our final answer would be ln absolute value 9 plus 3e to the x plus c. That's our final answer right there.